In Module 3, Lesson 17, we're looking at the area of a circle, extending our knowledge from Lesson 16. Now in the opening exercise, we're going to do a little working backwards. They're asking us to find the radius of a circle if the circumference is 37 and 68/100 inches. And we'll use 3.14 as the approximation for pi. So if we have the answer, remember that circumference equals 2 times the radius times pi. So working backwards then, if we know that the circumference is 37 and 68/100, we'll put in the rest of our formula, and of course putting in pi, and we'll solve for r. Two times 3.14 would be 6.28 times r, and then we'll divide by 6.28 on both sides. And our radius is approximately equal to 6. Next, we'll look at the area of a rectangle. Now, two ways that we could find the area of this rectangle. We could count the square units, or we could calculate by multiplying length times width. And either way, we would get 24 square centimeters. And then, if we want to find the length of a rectangle, if the area is 27 square centimeters and the width is 3 centimeters, we would take our formula, which again is length times width equals the area, and we'll substitute some number times the width. So we'll put the width first. 3 times the length is equal to 27. And when we solve by dividing by 3 on both sides, we find that the length is 9. And these would be centimeters. To find the formula for the area of a circle, we could cut the circle into 16 equal pieces, and then arrange the triangular wedges by alternating the triangle directions and sliding them together to make a parallelogram. So when we cut the triangle on the left side in half, this one right here, on the given line, and then slide the outside half of the triangle to the other end of the parallelogram, we have an approximate rectangle. The circumference is 2 times pi times the radius, where the radius is r. Therefore, half of the circumference is pi r. half of our circumference, which is the distance across this approximate rectangle. Our radius, which is the width. Now, thinking this through, our length would be pi times r, and our width would be r, the radius. The area of this rectangle, then, would be pi times radius times radius. Or pi times radius squared. Are the areas of the rectangle and the circle the same? Absolutely. But it definitely is not very practical for us to take every circle and cut it into wedges, fit them together to make a rectangle. So our formula then for the area of the circle seems a little different, mainly because we're not cutting every circle into wedges and laying it across to make a rectangle. In example 1, we're asked to use the shaded square centimeter units to approximate the area of the circle. So take a moment to count the squares. And then we're going to calculate a little more closely, and we're going to find out what the radius of the circle is. And I find the radius of the circle to be 10 centimeters. A quicker method for determining the area of the circle, other than counting all of the squares in the entire circle, would be to use the formula we just determined up above, which was area equals pi times radius squared. And so in this case, our area would be 3.14, we'll approximate with 3.14, times radius squared, which is 100 in this case. And so it follows that our radius in this case is approximately equal to 314 square centimeters, because we are talking about the space inside the circle, so those are square units. 1/4 of the circle was approximately equal to 79 square centimeters. And if we multiply that by 4, we would get 316 square centimeters. Now you may wonder if it's okay for us to have gotten two different answers, one by approximating from our wedge and counting squares, or one by calculating using the traditional calculation. But they are very close to each other, and remember, every one of these answers is an approximation because pi is a non-terminating decimal. So it's perfectly fine. In example 2, we have a real-life problem in which the sprinkler is rotating in a circular pattern and sprays water over a distance of 12 feet. We need to find the area of the circular region covered by the sprinkler and express our answer to the nearest square foot. So we're going to be rounding to the nearest square foot. First, we might draw a circle to solve the problem. So I've drawn a circle, and then I've drawn a line across the circle because it tells us that it sprays water over a distance of 12 feet. So I can assume then that that means a full distance of 12 feet. If I label that, we can clearly see that that is a diameter of the circle. So in order for us to find the full space that's being covered, we need pi times radius squared. So we need to know what the radius is, which is half of the diameter. And we'll make a little notation here. Radius equals 6. And then, to find the area, we would square 6. And multiply times pi, which we'll use as 3.14. So this is 36 times 3.14. Which is approximately equal to 113 400 square feet. And the question that arises, because this is another one of these rather ambiguous problems, is the 12 feet the full distance as the sprinkler rotates, or is the 12 feet half of the distance, which would be our radius? So if the radius is 12, then our area would be 12 squared times pi, or 144 times 3.14, and that is approximately equal to 452 1,600 square feet. And it's important to note that when we use these different measurements, even though in this case the radius is half of the radius in the second case, you'll notice that the area of the circle increases much more than just by twice. So using the wrong number for our radius has a huge effect on the answer. In example 3, Suzanne is making a circular table out of a square piece of wood. The radius of the circle that she is cutting is 3 feet. We want to know how much waste she will have for this project, and we'll need to express our answer to the nearest square foot. So first of all, we should draw a diagram to help us. And I'll start with the circle and then we'll put a square around it. Now I have a circular table. It's being cut out of a square piece of wood. The radius of the circle is 3 feet. So let's go ahead and draw that. And we know that this is 3 feet, the radius. The radius is also halfway across the square. So the information that we need is the diameter. We actually need the radius, the diameter. We will need the area of the square and the area of the circle. So in that order, our radius is 3, our diameter is twice, this radius is halfway across, the diameter is twice that, which is 6. Let's calculate the area of the square. The diameter would be the length of a side, so 6 times 6 is 36. And these are square feet. And the area of the circle will be pi times radius squared. So radius squared is 9 times pi, which is 3.14, is approximately equal to 28 and 2600 square feet. Now the solution still has not answered the question, because now we want to know how much waste she'll have. And the waste will be the area of the square that was not used for the circle. So in order to solve that, we'll need to subtract and we'll get 7 7/74 square feet. They asked us to express our answer to the nearest square foot. So we will round and that rounds to 8 square feet. In the exercises, we'll practice a little more with finding areas of circles and doing problems that involve area of the circle. If circle has a radius of 2 centimeters, and they're asking us to find the exact area of the circular region, our exact area has to be written a little differently. Remember, the formula for area of the circle is pi times radius squared. So if we square our radius, we get 4 times pi. And since any other use of pi, 22/7 or 3.14, would be an approximation of its value, the exact area is shown as 4 times pi, and we leave it like that. On the other hand, if we're looking for the approximate area using 3.14, then we'll take our radius squared, which is 4, and we'll multiply it times 3.14. And the approximate area is 12 and 56 hundredths square centimeters. Let's go up and label this one as well. And make sure we have that clear. If they're looking for the exact area, you will have to give the area in terms of pi. This is what it means when we say in terms of pi. But if we're going to approximate, normally the problem will tell us what to use to approximate pi. If it does not, and you're going to find the approximate area, then typically we do use 3.14 more frequently. In number 5, the circle has a radius of 7 centimeters. If we want to find the exact area, remember we'll square the radius. 7 squared is 49. And in terms of pi, that would be 49 pi centimeters squared. The approximate area using 22/7 would be 49 times 22/7, which is approximately equal to 154 square centimeters. Then we're asked, what is the circumference of the circle? So we have to think back to our formula for circumference, which was pi times diameter. So our diameter would be 14. 14 times 3.14 is 43 and 96 hundredths. And those units are just centimeters because you could cut the circle apart and lay out the circumference on a ruler. It is not square units. In number 6, Joan determined that the area of the circle below is 400 times pi square centimeters. Melinda says that Joan's solution is incorrect. She believes that the area is 100 pi square centimeters. We need to determine who is correct and why. So we'll do our own calculation for the area of the circle. This circle has a diameter of 20, and our formula for area of the circle is radius squared times pi, and the radius is 10. So if we square 10, that's 100 times 3.14, which will be 314 square centimeters. And so Joan would be, oh, gee, they're giving it in terms of pi. So 100 times 3.14, or 100 pi. So Melinda is correct. 100 pi would be the exact area and again, make sure that you are looking clearly at the question and answering exactly what they're asking.